Okay, so thank you everyone for taking the time to come to the Physics Society LaTeX Workshop. So for this workshop, we will just be going through the very basics of LaTeX to help you get started. Yeah, so like after this workshop, hopefully you will be able to type simple lab reports or simple lab summaries. And the most important thing that you will realize from this workshop is for LaTeX, right? If you don't know anything, you can just basically Google, because like any question that you have for LaTeX, you will find that somebody else has the same question as you and has already asked before somewhere online. So so first I'll pass the time to Justin, who will be talking about uh, uh, LaTeX documents in general, followed by equations. Then I will come and talk about tables in LaTeX, how to insert figures, how to insert PDF pages, and lastly on how to do your graph in LaTeX. Yeah. So Justin, you can take over now.
Okay, thanks, Darren. Yeah, and thanks everyone for coming. So yeah, before we even get started, I hope that all of you have at least a platform to run LaTeX on. So if you don't already have, right, please go over the website overleaf.com and just create an account there. It's very fast. Like you can just use your Gmail or something, then you can create an account. But it's okay if you haven't created an account yet. Later I'll run through briefly how we're going to create a LaTeX document. Okay, so don't worry about that. But just stand by the website for now. So yeah, okay. Yeah, thanks for coming, everyone. So welcome to our LaTeX workshop. So if you are new to LaTeX, maybe you don't know what it is, right? Some people, okay, so LaTeX is basically a documentation software where you can like write, it's like Microsoft Word, but much better because like you can control everything. So it's like, it's a very good tool to like write your lab reports or write maybe some of your essays, especially for physics majors where we have to do a lot of like equations and stuff, or to do your maybe a thesis or project or report or stuff like that. So I can show you, I'll be going through some of the things that you can do on LaTeX. But yeah, it's a very good documentation tool. And I think, I feel like once you get used to LaTeX, you won't really want to go to Microsoft Word to do your lab reports and stuff anymore because it's just so convenient. So yeah, I'll show you some of the stuff LaTeX can do, okay? Right, so what we'll be covering today is the basics. So like right from the very start. Oh, sorry, I realized that this share. Oh, okay, sorry, my bad. Okay, yeah, so there's a couple slide because I spent time on it and I want to show it off. Okay, so here's the contents. Right, so we'll be talking about creating your document. So right from the very basics, we'll be talking about like text and document formatting, packages, a brief intro in the packages, won't be going too in depth because that's quite a big topic. Equations, because I'm assuming most of us are physics majors, so we'll be having to type a lot of fancy equations and stuff. And yeah, tables, figures, and graphs, which Darren will be going through. Right. Halfway through to 193. Right. It's okay, don't worry. So the second half is where y'all can improve all your lecturers. So yeah. Right. Okay. So right, we'll start off with creating a document. So I'm just gonna, so how the style of this workshop is gonna be like this. I'm gonna give you a brief overview of the content. Don't worry, it might be hard to keep up. But then at the end of every section, I will just switch over to LaTeX and then I will code alongside with y'all. So then y'all can just see what's going on. Yeah. So don't be worried if you're overwhelmed with information. Okay, then when I switch over to LaTeX, you can just follow along. So yeah. So LaTeX has a few document classes. So there's a few things that you can do in LaTeX. There are a few types of documents you can create. This is a table of the documents, but for physics majors, right, I would say most of us would typically be spending time on articles and reports. Unless you're, I don't know, maybe some lecturers, they like to use Beamer slides formats and stuff like that. But I think most of us will stick to articles and reports. And even, let's say you're doing a lab report, right? You will typically use the article format. So I'm going to show you what the article format looks like later. So don't worry if you're a bit confused. But I think if you're doing like an honors thesis or something, you might use a report format. But other than that, other formats won't be really touched by us as physics majors. So I won't really be covering them in this workshop. If you want to learn more, you can always just Google, okay? Yeah, so right from the start, let's talk about an article. So this is how an article like an article in LaTeX looks like. So as you can see, it looks very similar to maybe what we might expect our lab reports to look like and stuff like that. So you have typically you have your title and your name and stuff over here, and then you have your content over here. Yeah. Or you can, so this on my left is actually a 2-column document. On my right, it's just the same thing, but it's one column, like one singular paragraph and stuff like one single column with multiple paragraphs and stuff like that. Yeah, so this is how it might typically, how an article would typically look like. As for a report, it looks a lot more like this. Like, I don't know if you've ever seen like, so this is actually PC2130, the notes. So it's actually in a report format. It's also what you would expect from maybe, let's say if you do an honors thesis, it might look something like this. You might have a cover page, right? Where you just talk about the like what the title of your thesis might be, followed by a content page. And then, yeah, then there's this like like there's big sections that cover, encompass everything and stuff like that. So that's how a report typically looks like. So yeah, I think right off the bat, y'all can see some of the differences. Okay, in LaTeX, actually, there's 3 default font sizes. So there's the 12 point, 11 point, and 10 point. You can see the differences here. So if let's say you want to do something else, like you want to do a 9 point or 8 point font size, right? Let's say maybe you want to, your lecturer tell you that you have to keep your assignment within 3 pages, then you want to make, and then he never specify font sizes, then you want to abuse that, right? Then you want to use 9 point, 8 point, that kind of thing. Okay, don't. First of all, don't. But second of all, yeah, LaTeX doesn't really support that unless you use like a special package and stuff like that, which I won't really be discussing in this course. So
doesn't support what?
Yeah. Sorry? Yeah,
doesn't support what?
Oh, it doesn't support other font sizes. So as in default font sizes. So if you want to use other font sizes, you'll probably have to use a package, which I will discuss later. So you can only use 10 point, 11 point, and 12 point font sizes as the default. Yeah. Does that make sense? Did I answer your question? Right?
Yeah, makes sense.
Yeah, okay. So yeah, so sorry, because like there's a lot going on my screen right now. You know when your lecturers always say like, they always like complain, there's so much going on the screen.
Justin, I will help to answer some of the questions. Like you don't have to always look at the chat. I will help you.
Right, great. Okay, thanks, Darren. Right, so yeah, that's yeah. So these are the typical font sizes, as you can see lah. You can see how different it looks. Right. Let me just adjust the screen. Okay. Next, briefly, Darren will be covering this in a lot more detail later on, but like basically, a 2-column document might look something like this. Like you can have the 2 columns in LaTeX, which I think it's a lot harder to do in Microsoft Word, honestly. But like in LaTeX, you just have to specify that you want a 2-column document, and then it will just nice do everything like for you, stuff like that. All right. Margin. So if you don't know what a margin is, basically the little spacings at the sides. So these are the margins of LaTeX. And in LaTeX, you can manually specify your margin. So like you can really type in what I want the left side to be how small, I want the right side to be how small, I want the top to be how small, that kind of thing. Yeah, so you can do that in LaTeX. And indentation. So what do I mean by indentation? If you look at this is a typical LaTeX document, right? If you know, I don't know if any of you all notice anything particular about it, but if you are typing in LaTeX for the first time, you might notice that the second paragraph of every like section, right, has a spacing. It starts with the little 2-paragraph spacing. You know, like in primary school when you ask to put the 2-finger spacing before you start writing. Yeah, like LaTeX does that. So this is the indentation. And there are ways to overcome this. If you don't want an indentation, there are ways to do this, and I'll teach that later. But just take note that LaTeX by default it does this. Yeah. So right. So I've covered a lot of things already, and you might be a bit overwhelmed. What am I even talking about? Okay, this is the first time we are going to talk about some LaTeX code. Okay, so this is how LaTeX code looks like. And this is how we specify everything that we've discussed so far. Okay, so one by one, okay? Remember from the start, I talked about the different types of document classes, right? Like articles, reports, books, and stuff like that. We only typically use articles and reports. So when you specify that, you specify that with the very first line of code. Like you just comment this document class, and then you put the curly brackets, and then you put article or report. Okay, so this is for you to specify your document type. You can put optional inputs. So meaning the things in the square brackets are optional inputs. You don't have to put them in, but if you want to specify more things, you can put them in. Like for example, you want to specify your font sizes from one of the 3 default font sizes, which I stated just now. You can just specify. You want a 2-column document, you can put it in here, comma 2 column, or if you don't, it's also fine. It'll just do its default thing. LaTeX will just do its thing. You can play around with it later. Okay, so remember when I told you about the indentation, the paragraphing at the start, when you see the two finger spacing and stuff like that. If you don't want, you can actually play with that using this command called set length. So set length, then curly bracket, par indent. So if you don't want that two finger spacing at the start, every second paragraph, you can just put this command, this par indent, then 0 point. So 0 point just basically means you don't want that two finger spacing. It's a bit confusing now. Okay, don't worry. We'll get to try it out later. So if you're using 2 columns, sorry, you can later on Darren will be covering a package which might make this to be easier, but you can also okay, so you can define your margins using these commands. So like set length, the column separation, then how long you want. So the set length is for the column, the spacing in between 2 columns. Or if you want to define the margins manually, you have to use this thing called a package, and then this package called geometry. So as you can see here, I specified like my margins. I want overall to be 1.5 cm, but I want the top to be 1.3, the bottom to be 3 cm. So this is how you would specify your margins. Okay, so next, even more packages. You can input so basically what packages are basically things that will help you to write your document later, like things that are not built into LaTeX. You have to call it out, like a special little functions that have been defined for you previously. Okay, it's a bit, don't worry, we'll go through all of this right now. Just get a rough idea of what's going on, then later we'll get into the meat of it. Okay, how would you specify a title and stuff? So yeah, you can put your title, your who you are, your author name, and your date. So all this will appear at the top later, and the little title at the top. And then very important, you need to tell LaTeX that you want to begin your document. So you have to click the begin document. Oh, sorry, I didn't change that, but it's just basically a command for you to begin your document. And then the make title for LaTeX to put the title at the top. Right, so that's kind of the end of our first section. We covered quite a lot. So, okay, let's go over to Overleaf right now, or any LaTeX software that you currently have. And we'll try coding. We'll try creating our document. Okay, so yeah, so all of you can just turn on your. If you are capable of doing like maybe 2 screens, like the left screen is the Zoom call where we can do side by side, and then the right screen is Overleaf or any other LaTeX documentation software that you have. Yeah, you can set that up. Okay, we're going to start our first session. Okay, so right here I have Overleaf. If you have created an Overleaf account, this is what you would see. So if you're using Overleaf and you're following along, yeah, you can just click new project and yeah, click blank project. For example, maybe, okay, project name, the LaTeX Workshop. Yep. So it's going to do its thing. Right off the bat, you can already see that LaTeX is, Overleaf is super friendly in that it already defines like all the basic stuff for you already. Yeah, so, but if you are using a different software, right, it typically won't start like this. It'll start off completely blank. So let's take a look at what we discussed earlier on just now, right? So first of all, we have the document class. So you specify whether you want an article or report. I think if you change to, so if I believe if I change to report right now, you will see the difference. For example, this title screen over here will become a separate page on its own. Let me see if it does that. Yes, you see, so this is a report style, like there's a cover page and everything. Like it's very formal, like really like report that kind. So typically, if let's say you're doing a lab report, like all of the 2193, 3193 want to impress your, I don't know, want to impress Prof. Nikolai or something, then typically we will just use article as our like lab report style format. Okay, so yeah, Next, you can, so when I said about the margins and stuff, right? Let's say you want to play with the margins. So we're going to use a package. I'm going to cover packages a bit more in detail later, but basically packages are things that help you do things in LaTeX. So they're just like helpers, like, you summon a helper to help you with your LaTeX battle and stuff. I don't know. So yeah, so if you want to manage the margins, just click, I want you all to help me import the package, use package geometry. Okay. Geometry, all right. Then, for example, margins, right? If you want to specify the margins, use square bracket in between the use package and the geometry. Click key in margins, maybe 1.5, then you can specify the length. So if I were to recompile my document right now, right, you all will see, do you see the lengths at the sides change, right? Now it's all 1.5 cm. So if you want to spread out, if you find that the sides of the pages are taking a lot of space, right, you can just use this package called geometry and specify your margins. Yeah. All right. Title. Now I call this LaTeX Workshop. Let's say I want to change it to what something silly, like maybe, I don't know, band cap of germanium, for example. Okay. Then you recompile, you see the title changes as well. All right. Your author can be you. It should be you. Then who else is it going to be? So you just type in your name, right? Like my name is Justin. So you can type Justin. Then you see the name will show up. Okay. If you want to type in your metric number below your name, what you can do is to just key in a double backslash. So this double backslash is actually in LaTeX is basically your enter. You press enter to go to the next line. So LaTeX reads a double backslash as enter as in go to the next line. So then you can key in your metric number, maybe A1, 0, 1, 2, 3, 4, 5, 6, X. Okay, then you recompile, you see your metric number appear at the bottom, right? Date. Okay, so date, LaTeX normally just fills in the date for you. But if you don't want the date, let's say you don't want, it normally demands that you key in a date. I believe if you erase the date, it will give you an error. Oh yeah, it still appears. The date still appears. So like LaTeX is like, so if you are the kind that like to do your homework in the last minute, and you don't want your profs to know that you were playing with your LaTeX document the night before it was due, right? So you don't want to put the date, for example, you can just put date, then curly braces, but inside there's nothing. So when you recompile, you notice that the date disappears. There we go. Yes, right? Okay, so very important. I think a common mistake people make is that they sometimes when they start off, right, then they start typing their document, but they forget to key in this command called begin document, in which way you begin your document. So if you don't do that, like, and you just like, I don't know, for example, you just type, hi, this is my report, and then you compile, I think it should, yeah, it just straight up gives you an error. It just breaks down, like it just doesn't understand what's going on. So you make sure you start your document by saying begin document. Then you say make title. So I believe if you don't key in make title, the title doesn't even appear. There we go. Yeah. Okay. So if you want the title at the top, click make title. Okay, section, I will introduce that in the next portion of our workshop. And then, of course, if you begin something in LaTeX, every time you click a begin command, make sure there's an end command also. So if let's say you erase this, sometimes you get very excited, you press begin document, then you type, then you never click end document. You never specify end document. Once again, it gives you an error. All right, so that's all. So if you have been following along, you have already created your first LaTeX document. All right, quite simple, right? All right, everyone good? Anyone not okay? Okay, all good? All right, cool. Anyone needs more time? Can we move on to the next portion? Anyone got questions? You can unmute or you can say in the chat. All right. I'm guessing everyone's very excited that they created their first LaTeX document. I'm very excited. All right, so, okay, all good? All right, let's move on to the next portion. Right, okay, so this is where we end off last time. Yes, so we're moving on to text and document formatting. So all good, yeah. thing. So since you reply, it's okay. If you all don't reply, it's also cool. But just checking if you are still okay, if the information is not too much. All right. Okay, so now we move on to the next portion, like text and document formatting. So right from the start, we should like one thing I want to introduce is things like sections, subsections, and chapters. So in a report, right? In a report, let's say you want to define a chapter. So I start with report first. So report, there are like several levels to, like in Microsoft Word, let's say for example, you want to specify a header, right? Like let's say now you're going to talk about introduction, then you write introduction in bold, then you type your introduction, then you go to the next part, like my experimental objectives, then you type that. So this is basically what it is. Like if you want to do that in LaTeX, you can specify a section. Maybe your section is introduction, then subsection introduction to semiconductors or something. I don't know. So in a report format, let's say when you're writing a really, really long report, sometimes you will have separate chapters, right? Or separate portions, separate sections. You will type chapter, you will type \chapter, but it's also okay if you don't do \chapter. In reports, it's okay if you don't do \chapter, it's fine. Then this portion over here, this chapter 1 chapter does not appear, right? So, okay, basically what you do is you type \chapter, then you type the name of your chapter. So if let's say I type \chapter, the story of Bob and Alice, for example, then here will appear the story of Bob and Alice. So the reason why it appears as chapter here is because I typed chapter here. All right, everything okay? Everybody okay? Then you just type maybe some text at the bottom, whatever you want to type. So you can say this chapter teaches about section and chapters, for example. Then you can type \section. So section, there will be sections. Like, so you have the chapter, then you have the section. So maybe like 1.1, then you'll put section. Like maybe you can put like introduction, that kind of thing. Then you type even more text, for example. Then you have subsections. So in between the section, there's another layer subsections. So then you can type whatever you want. Then after that, there's actually there's also subsections. So basically in subsections, you notice a few things. First of all, your numbering disappears. So you'll find that there's no more numbering. It's just a bold text as a header. Then you can type whatever you want. This is for reports. Okay. So this is what's chapters, sections, subsections, something like that. Okay. For articles, they're a bit different. So in articles, if you type \chapter, then you type the chapter name, it doesn't even register. It just like, I believe in some LaTeX documentation softwares, like maybe if you do like Text Maker or you do Text Studio or something, it might give you an error if you do \chapter and you do an article. Whereas, so article does not have chapters. Okay. Instead, articles, the highest header that you can start with is sections. Okay, so you have a section, then you have a subsection, and you have a subsection. Notice the different thing in articles is that in articles, the subsections actually have a number. So it's 1.1.1. Oh, so many numbers, right? 1.1.1. So yeah, that's something you can do, something you can take note of. I in my experience so far when writing lab reports, I don't think you ever need a subsection. I mean, like, but like, it's there if you ever want to use it. Feel free to, you know. Okay. Right. So, content pages. Content pages are exclusive to. No, wait, that's not wrong. That's not right. Content pages appear in both reports and articles, but in articles it's very weird because remember your titles. So that if you remember just now when I showed you the difference between reports and articles is that reports, your title start on the very first page. The whole first page is your title. But on articles, your title is on the first section, right? Then it's your stuff. So you do a content page on an article, you have your content page that starts first. There's no cover page. It's just content page. Then after that, your title appears on the next page. So I would say doing content pages on articles are quite silly. Don't really make sense. But so I would say content pages, try and use them only for reports. If you want a content page, that means you're writing a lot of stuff, right? If you want a content page. So I would say use reports as a format. So all you have to do if you want a table of contents. So remember just now I told you about your sections, subsections. If you've been doing this, you use the code section, you use the code subsections and stuff like that. Magic, all you have to do is put table of contents and your whole table of contents appears. Like, yeah, it's like, wow, that was easy, right? Like, oh my goodness, yeah. So then you can see here. So like, this is once again, I borrowed from PC 2130. So you can see like the chapter name appears here, then the sections, then the chapter name, sections, then there are subsections and stuff like that. Sorry, subsections, not subsections. Yeah, so you can see how it looks like. All right. Okay. Comments. So like, I don't know if any of you are familiar with any other programming languages before, but typically in other programming languages, sometimes you can leave, when you code something or something like that, you can leave a comment, right? Like you can tell other people who are reading what you wrote, right? What you're trying to do. So in LaTeX, it's no different. LaTeX, the way to write comments is use this percentage sign. Yeah. So as you can see, so right here I have my input box and my output box. So input box is what you key in your code. Then output box is what appears in your PDF document or something. Okay, so if you type like this sentence will be shown without a percentage sign, then it will be shown. But if you type percentage sign, right, then you type whatever sentence you want after that, it doesn't show. So the percentage sign is used for you to comment things. Yeah, simple as that, right? So if you don't want something to appear in your document, but you want to type it in as a note to yourself, what you are trying to do, right, you can just use the percent sign. Okay, and since we're on the topic of the percent sign and stuff, right? So these are a list of reserved characters in LaTeX. So what do reserved characters mean? Basically, if you are typing anything, right, like you are typing in LaTeX and stuff like that, and you use any of these characters, LaTeX is going to give you a problem. Like the character will either not appear or it will just give you an error message. So like for example, let's say I want to type Alice transferred $500 to Bob. Then I put the dollar sign in front of $500. Then I ask LaTeX to compile the document for me. It will give me an error because the dollar sign is a reserved character in LaTeX. It's reserved for a specific function. And this function is actually called math mode, which we will discuss a bit later. But yeah, so if you want to type the dollar sign, you have to do this thing called like a backslash. Basically, you have to do the backslash for the dollar sign to appear. And there are a list of other reserved characters too, you can see over here. Yeah, and what they do. But if you're just starting off LaTeX, all of this is going to be very confusing to you. Just key idea, any of these characters, if you try to type them just raw characters, they will give you an error or they'll give you a problem. It won't appear, right? Okay, if you're all good, shall we go back to overleaf and then we try again? We'll try and play around again. All right, or fire up that LaTeX document software, whatever that you're using, TextMaker, Text Studio, overleaf. We're gonna go back and try and start coding together again, all right? Right, so I'm back, right? You're back? Okay, I'm guessing you're all back. All right, so LaTeX, as in if you're using overleaf, it's already nice enough for them to specify the first section for you already. So like for example, you can type section introduction, or for example, then maybe your next section will be maybe experimental procedures. For example, then you will see all the headers will appear, right? Wait, can you see? Oh yeah, you can see. Okay, so if you want a subsection, for example, you just type subsection, then I don't know, setting up of, I don't know, whole probe, I don't know, whatever. Okay, then you'll see the subsection appears. All right. Okay, so these are sections and subsections. So if you want below your section, you can type anything. In this experiment, I play with the whole probe and germanium sample. Okay. So then you see the text appears below. Right? Yeah. Okay. So I'm going to switch over the report to show you how it looks different in a report. Okay. So most of you won't be using report anytime soon. Maybe eventually, if you all do your FYP and stuff, then you will use, but probably not anytime soon. But if you switch over the report, you can see how different it looks. Once again, remember, the first page is your title. So your title doesn't appear here. Okay, you see your numbering is all different also. I'm not going to go into how we change the numbering because I'm assuming most of you aren't going to use a report. If you all want to learn, you can always feel free to Google, but you can see how different it looks lah. But one thing I want you all to know is that LaTeX has chapters. So basically you can put backslash chapters, not LaTeX has chapters, sorry, reports have chapters. So you can put backslash chapter, then get Germanium, for example, okay, some random chapter, and whatever you place in your curly brackets over here, you'll see it appears as your chapter name. There we go. And then your numbers also change accordingly. There are ways to manually change the numbers and stuff and all that if you want to get rid of the numbers entirely, but we won't be getting into that today. Okay, if you want to do that, you can just Google. Yeah, so this is how a report looks like. And remember when I told you about the content page? All you have to do is table of contents. Was it table of contents? Please be correct. Yeah, there you go. Okay, I have no idea. Oh, because, okay, sorry. So make sure you put the make title. It's a typical programming software, so it will always run the first command first, right? So if you want the title to appear in the earlier slide, yes, please do that. Yeah, right. So you can see the table of contents with all your sections and your subsections. Now, if you try and change back to an article, right, you'll notice a few things. First of all, I mean, it looks very silly, right, with your title at the top and everything kind of jammed together. So this is why I would say if you want to do a content page, you should be using a report format. Second of all, you notice that chapter does not show up in an article. So what does it do instead? It just doesn't show up. No, it does. Okay, so it shows up over here. Yeah, you see this little band gap of germanium. Yeah, so that's where it shows up. It just shows as normal text. So I think if overleaf, it will show it as normal text. If you're using like TextMaker or Text Studio, it will just give you an error message. So yeah, if you're using an article, there's no chapter. Bye. All right. Okay, last part we covered the reserved characters, right? So remember, if I want to give a comment, let's say I want to remind myself like to update this portion later. I'll say talk more about stuff here. I don't know. Okay, if you compile, you'll realize that, okay, let me get rid of the table of contents first. If you compile, you notice that actually, you all will notice that the text doesn't even appear, right? But if I were to remove this % sign, then it does, right? So yeah, okay, also one more thing to take note. One thing you all may have noticed is that in addition to the little paragraphing that I told you all about earlier, LaTeX doesn't, you notice if you press enter on your document here, the lines still join together. So if you want to space them very far apart, right? You compile, it still joins them together. So what the heck? Okay, so basically what you should do is you can remember what I told you all earlier about the double backslash, how it functions as an enter sign in LaTeX. So you can just do a double backslash and it will jump into the next paragraph. That's the paragraphing. So if you want to have the paragraphing, you all can do that. Once again, remember the 2-finger spacing here. If you all don't like it, you all want to get rid of it, right? There's 2 ways. One is you all can use this command called no indent and recompile. Yeah, and then it's gone. Okay, but if you then you do a new paragraph. Let's say you do a new paragraph, talk about more stuff. Then it has the same problem. It has the double paragraphing again. So if you don't want to do no indent on every single line, right? What I would recommend is that you all just key in this thing called set length. Then you all click backslash par indent. Then you put 0 points. So what is it? You are telling LaTeX to just, I don't want the indentation. Please get rid of it. Okay. All right, so far. Okay. Okay, back to the special characters. If you put special characters like I want to give my 100% today. Do you notice there's a problem? it's like you will notice that everything after the percent sign goes away, right? So you have to do a backslash percent. Okay. Same for dollar signs. I want to give, instead of 100%, maybe I want to give $100 today. What will you notice? You'll notice the the dollars like disappears and my 2 day joins together. There's a reason for this. LaTeX is entering math mode, which we will talk about later. But if you want the dollar sign, just click backslash dollar sign. All right. Okay. So far, so good.
Justin, do you want to do the backslash? Because in your slides, you say to type backslash is just backslash, but I mean forward slash.
Oh, forward slash.
Like,
sorry.
yeah, you want to show them how to do forward slash because it's a bit different.
Right, forward slash.
No, I mean the one for the command one, that slash.
Oh, you mean the backslash?
Yeah, backslash. I'm not sure if front or back, but yeah, backslash.
So like this, if you just want to type backslash.
Like, it doesn't work. It should be, there's a command to type backslash. The command is backslash.
All right, backslash.
Is it? I looked up. I spit out something about a math mode error or whatever.
We'll talk about it later.
Wait, how do you do forward slash then?
It's just forward slash.
Yeah, so forward slash would just be forward slash. This forward slash is not a reserved character. That's right. Yeah. Okay, but Darren brought a good point. Sorry, my mistake. The slides are erroneous. I will edit them later. Oh yeah, so I assume Darren will help distribute the slides later. Okay, so you all don't have to worry so much if you all cannot keep up. You all will have the slides to refer to after this. But yeah, so if you want to type backslash, sorry, you just type backslash. Cool, right? Okay. Oh, okay. Everyone okay? All right, cool. Nice. Any questions? Please stop me, okay? If I'm going too fast, if I'm rambling on too much. Cool. Share. Right. So sorry, this is wrong. I will change it. Okay. Any questions before we move on to packages? Right. So in packages, what are packages? Packages are basically okay. So imagine like you want to do a bunch of stuff. Someone is like okay. So basically, packages are things to help you do stuff. Like for example, like you'll see the usefulness of them later. But like for example, just now when I talked about the margins, I already introduced the package, right? The use package geometry. So that's the geometry package. Basically, someone has helped you already make a function that help you define your margins, for example. Like so you don't have like basically someone has made your life easier, and then you can just call on that package to make your life easier. Okay, so packages are very useful. They help you do a lot of things. So I'm going to show you a few of the commonly used packages. These are the common packages that we use in LaTeX. As physics majors, please import the physics package because so you just click. Okay, so how do you import packages? You just click backslash use package, then curly brackets. Inside the brackets, you key in whatever package you want. So this package, this physics package, is so useful for physics majors. It's not even a debate. It's like better than the AMS math package, but there are actually things that the AMS math package that can do that the physics package cannot really do. So just import everything that you see on screen here. I'm gonna I believe Darren will just copy and paste so on the chat. So you'll just copy and paste into your text document later. Okay, so yeah, these are the packages that are very useful. So okay, the physics package, when I say it's very useful, right? It's basically because it helps you do a lot of physics equations. Like, okay, like you can type, for example, in quantum physics, you can do like brass and cats, like super easy if you use the physics package. Or it helps you even type derivatives and integrals very, very easily. It even has some special matrices already defined for you, like the Pauli matrices and stuff like that. You can just call on them and then it just appears. So if you ever want to learn more about a specific package, right, all you have to do is just Google. Because like if you Google LaTeX physics package, there's this PDF document that appears that shows you every single thing the physics package can do, which is amazing. There are always these PDF documents that somebody compiled what the entire package can do. Then you can read through and then like, oh, what can this package do and stuff like that. So the key idea packages are basically like they contain a bunch of functions that people already defined for you to make your life easier. That's the key idea. Okay, so you just have to import them and it makes your life a lot easier later. All right. Okay, so okay, that's all for packages. Let's go back to Overleaf or whatever you're using to import those packages. Right. Okay, so where do you import your packages? Your packages come before you even start your document. So you do not import your packages after the begin document command. Okay. So you don't put begin document, then you define your packages, for example. I believe you will have a bad time. Yeah, so you can see all the funny names come out over here at the top. Okay, so that's not what we want. We want our packages to be on top before we even begin our document. So they go over here where with my geometry package, which I already defined. Okay, I'm just going to get rid of, no, actually, you know what, let's keep that. I'll get rid of this geometry package. Okay, so you put your packages in here after you put your document class. Then you compile, it doesn't appear anymore. It doesn't appear in your document anymore. All those funny names don't appear in your document anymore. All right, that's all you have to do. So please copy and paste those packages into your LaTeX file if you're following along. Cool. All right. Okay. So now we'll move on. Anyone still needs more time? If you need more time, it's okay. Okay, just let me know. You can shout out in the chat or you can unmute and let me know. All right, now we'll move on. Okay, so we're going to talk about how to do equations in LaTeX now. So I'm assuming most of us are physics majors, right? Or if not, we're probably from science or something. So equations are like our I don't know, like our bread and butter, right? Like if you don't imagine you want to type an entire lab document without doing any equations or anything, any lab report without doing any equations or anything. How? Is it even a lab report? You know what I mean? It's like so we're going to show you how to do some common LaTeX equations. Okay, so LaTeX is super good, and like that's probably one of the biggest selling points about using LaTeX over Microsoft Word is how easy it is to type in like really long equations and stuff like that, and how it makes it look so nice and so neat. So you can do things like calculus notations and stuff like. So you can do integrals and partial derivatives and stuff like. You can do matrices and stuff like that. So yeah, a lot of cool things you can do on LaTeX. So first of all, right, if you're doing equations, right, so maybe you're very tempted to type your equation just like that. Like for example, Bragg's law states that this, and then you are even so good that you can pull out the Greek letter theta for me, and you can pull out the Greek letter lambda. Your computer can type in all this stuff, and then you click enter, very excited, right? You think your equation is going to show up, but what shows up instead? Look on the right. Okay, so this is your output. This is how your output's going to look like. Your output's going to look like, oh, where did my theta go? And where did my lambda go and stuff like that? And my equation looks a bit weird and funky, you know. So this is wrong, okay? This is not how you clean equations in LaTeX. So in LaTeX, remember, just now I briefly touched on this, but there's this thing called math mode. So you can enter an entirely new environment in which for you to type math equations. Yeah. So an entirely new environment for you to type math equations. So how do you activate this new environment? How do you like summon this new realm in which you can summon forth all your equations? So how you do that is just basically you type the command begin equation, okay, and then in between you put your equation, then you put an equation. Ta-da! Look, my equation pops up just fine. And okay, so I want you to pay attention to a few things. Okay, first of all, like I type the begin equation, then the 2D, then sign. Okay, so I put backslash sign. Why do I put backslash sign? Because if yours, I don't know if you're a bit nitpicky and stuff, right? Your sign function normally is not written in italics. You know, it's normally written in a normal font. So if you do backslash sign, it's just how you make your sign look like a normal sign. So if I don't put the backslash sign, I just type out sign. It will give me the entire sign function in italics. So we don't really want that, I guess. I mean, it's fine if you're not particular. Also, if you don't have those keyboards where you can like, I don't know if you feel it's very like tiresome to switch to a Greek letter keyboard and type in the letter theta. No worries, like LaTeX takes care of that for you. You just type backslash theta. And then look, theta appears. Wow. Same for lambda, same for any Greek alphabet you want. Yeah. So the idea is that backslash is kind of like calling a function. So the idea of backslash is every time you use backslash, it's like calling a function for you. Then LaTeX is going to recognize that function. Then it say, oh, this is what you want to do. And then it's going to give you the output, for example. Okay. So, okay. Yeah. Oh, and also take note. Okay. So if you're following along already, if you're already busy typing away already and you tried this, right? You might notice the proportions of this area might look a bit different. Like it might look a lot smaller on your screen. That's because I made the font size bigger for you all to see. Actually, the proportions are a bit different if you type in on LaTeX, and later I'll show you what I mean. But just keep that in mind in case you're wondering. I don't know if you're wondering about that. And okay, other questions you might have is like, how do I type capital Greek letters? So you all know like theta and lambda are Greek alphabets, right? So Greek alphabets also have a lowercase variation and an uppercase variation. So if you want to type an uppercase Greek letter, all you have to do is very simple. You just have to change the first letter of the Greek alphabet to a capital letter. So if you want to type capital theta, all you have to do is just backslash capital T, then the rest of theta. So like capital T, HETA. Simple, right? Yeah. All right. Oh, and last thing, you might notice that LaTeX gives you this equation number. When you call the equation function, right, begin equation and stuff like that, then there's this equation number. So it's very useful because LaTeX helps you label your equations. But sometimes you don't want that, like I just want to type an equation, I don't want the label there, So that's fine. How do you do that? You can do that in two ways. So one way is you can do this where you just backslash this square brackets, and then the equation number is removed. Wow, simple. But other than that, remember when I told you all the physics package is very, very useful. Okay, so other than that, if you don't want to bother with this square brackets thing, right? You can also just add an asterisk sign in front of your begin equation. So yeah, this asterisk sign, basically, whenever you add this asterisk sign in your document, right? Like let's say in your functions, you put an asterisk sign. It's basically telling LaTeX, I want to change the environment. So I want to change the environment slightly, or I want to change the environment completely, for example. So different functions have different changes. You will notice that different functions have different changes applied to them. And we will explore a bit of that later. So feel free to play around with it. So if you put begin equation, then an asterisk symbol behind the equation, notice your equation number disappears also. But you have to have imported the physics package. Okay, the AMS math package also can do this, but like, I mean, if the physics package can do it, like, but I mean, we have made your import both anyway, so no big deal. Okay, yeah. Right. So okay, now if you want to type equations in the middle of a sentence, right? Like you don't want it to be a new line. Like just now, remember I showed y'all when y'all put begin equations, you notice that it begins an entirely new line, then it puts the equation. If that's not what y'all want it on the same sentence. Y'all can call math mode in the sentence by using the dollar symbols. So remember just now when I said the dollar symbols are special characters that you cannot just write a dollar sign anyhow you want. That's the reason why. Because when you call a dollar sign, you're telling LaTeX, I want to summon this new realm where I want to type equations. So yeah, it's like then LaTeX. Basically, every time you summon this new math realm, right, you got to close the portal. If not, it will explode and your document goes haywire. So yeah, so make sure every time you put a dollar sign, you have the other dollar sign at the other end. Okay, so yeah. And as you can see here, capital delta, I just put the capital D at the start of delta. And it becomes capital delta. Wow. Life is simple. Right. Okay. Cool. Okay. Next, remember just now I talked about the special functions, the sine, cosine, tangent. This is what I mean. If you type begin equation, you type sine, cosine, tangent, for example, whatever, you'll notice that not only does it lump everything together, it becomes italicized. And I can tell you what LaTeX is trying to do here. LaTeX is basically trying to say, LaTeX is basically interpreting what you're saying as each letter is a variable. So S is a variable, I is a variable, N is a variable. For example, that's why it italicizes the whole thing. It doesn't take it as a sine function if you just do that. So that's why when LaTeX italicizes the thing, it just takes it as a variable. Okay, so what you should be doing, right? If you want to call sine, cosine, tangent, or an exponential function, there are other things like arcsine, cosecant, whatever, if you want to do that. It's also there. But of course, I can't type everything for you to see. It would be confusing, right? So just do a backslash, then do a backslash, sine, cosine, tangent. Look, nice, and it separates out for you because it knows what you're trying to do. It knows that you're calling the sine function. Like, I want to type the sine function. I want to type cosine function. Not, I'm not trying to say my variables are CO and S, for example. Okay. Right, cool. Okay, next, we're going to move on to fractions. So how do you do fractions in LaTeX? You just call this frac function. Frac function, basically you key in the numerator in your first little curly bracket, the denominator in the second curly bracket. Ta-da! Wow, it's a fraction. Okay, simple, right? Okay, so next, there are a few different kind of fraction functions, right? If you're using like TextMaker, I think the default fraction function, if you try to type a fraction function, they might give you dfrac instead. What does dfrac even mean? So basically, there are a few different types of fraction functions, but all of these can be found in the physics package. If you didn't import the physics package or you didn't import AMS math as your packages, right, you will only be able to use the first function, the frac function. Okay, if you imported the physics package or AMS math, you would have two other additional functions for your fractions, like dfrac and tfrac. So what does that even mean? Okay, dfrac basically means your fraction is in this thing called display mode. So display mode for fractions, you might not notice a lot of difference. The proportions, if you can pay attention very, very closely, you'll notice that there's a bit of a difference in the proportions and stuff, but it doesn't really matter. It matters more when later, if let's say you don't put your integrals in display format, then it starts to look very wonky, So for fractions, it doesn't really matter, but it's there if you want to use it. But okay, tfrac is probably the one where you notice a significant difference. Tfrac basically means I don't want my fraction to be the proportion of an equation. I want it to be the proportion of as if I was typing it in a sentence, like in text mode. So then it will shrink into really small. And then, so if you want to do that for some reason, you'll probably need to use that if you are typing in a sentence, right? Remember the dollar signs? If you are typing in a sentence and you don't want your fraction to be super big, that it explodes your entire sentence, you can use tfrac. All right? Okay. Okay, superscripts and subscripts. So if you want to call a superscript, so you all know what a superscript is, right? It's basically like this thing at the top. It's a superscript. You just have to put the little caret head superscript. Okay. If you want to use a subscript, right, then you put the underscore. That's all. So if you want E subscript K, put E underscore K. You want P to the power of 2, p caret 2. Simple, right? Okay. Okay, but next, let's say you want to type, like, for example, a word as your subscript, right? Let's say I want the total energy, right? So you put E underscore total, for example, like here, E underscore total. What do you notice? You notice there's a problem, right? Like, what's the problem? The problem is that only my T became a subscript. My O, T, A, and L, it's normal size. This is of course wrong. So how do I fix this? If I wanted to subscript the entire word, what do I do? Very simple. You just encompass the entire thing in curly brackets. Right. Simple, right? Okay. So yeah, same for superscripts. Okay. If, let's say, for example, you want the power of some word or something, you can just superscript and curly brackets. Okay. Like to the power of, like, maybe 2 to the power of pi over 2, I don't know, something like that. So 2, then you will do the curly bracket. The caret, then the curly bracket, then the fraction pi over 2. Okay, maybe that's a bad example, but you all get the idea. Like, if you want to do more than just one character, you have to do the curly brackets. All right. Okay, calculus notation. So let's say you want to do dy dx, right? Like, dy dx is a fraction, right? So you can just use the fraction function, dy dx. But I'm going to show you all in a moment that this is not the best way to do it, okay? But let's say you want to do like dy dx, you can do fraction dy over dx. Okay, but this is not the best way to do it, but you can do that. Same if you want d square y dx square, just put d square y dx square, fraction d square y dx square. So you can do this, but this is really not the best way. So remember I said the physics package is amazing. Okay, so you can use the physics package to help you write derivatives. Let me show you some of the stuff you can do. If you have been using the physics package, right, all you need to do is just call this command dv. So if you call this command dv, inside your curly bracket, you put the variable. Then, yeah, you can see it gives you d over dx. What? Then y. Then if you want two variables like dy over dx, right, then you have to call two of these inputs. You have to put two of these inputs. So like dv, open bracket y, or sorry, curly brackets y, then curly brackets x. You can see over here. Okay. Here's even more magic for y'all. If you all want like n derivatives, right? Let's say you can call this optional function in square brackets n. So it's dv square brackets n, then curly brackets yx. Then you see it comes out like this. So if you replace n with, let's say, 2, for example, then it becomes d square y dx square. Wow, simple, right? Then you don't have to type the whole thing. You don't have to type frac, then curly bracket d to the power of n, y, you know what I mean? So you don't have to do the whole thing. If you import the physics package, you will type a lot faster, a lot more concise. Okay, and also if you want to do the little line thing, right? Let's say you want to substitute in your variables after you do, like you want to define the variables in which after you differentiate, you want to substitute in the variables. You can just do this eval function, \eval. Then you sandwich your function inside. Okay, then then this thing is like a superscript, right? Sorry, this thing is like a subscript. So you call underscore 0. Then you want then this thing is like a superscript, so you call caret infinity. Okay, in this area, I included the infinity in this portion of the slides for a purpose, because I want you all to show you how to type infinity. But if, let's say, in LaTeX, let's say you want to type something and then you realize you don't know how to type it, you can always Google, right? But this is how you type infinity. So it's not IFTY, it's not ITY, or it's not IFY or INTY, I don't know. It's INFTY, okay? So you got \INFTY. Now, even crazier, the physics package can help you do partial derivatives also. So if you got the little inverted 6 thing, like you might be wondering, if you were to do without the physics package, you have to type the frac and all that. Then how are you going to type the curly little 6? The physics package can do that. So instead of dv, you put pdv, partial derivative, pdv. So you sandwich your thing, same thing, the numerator, the denominator, substitute, you sandwich it within the curly brackets x. Now if you want partial y over partial x, then just put y then x. Same rules as your derivative. Okay. Here's the crazy thing. So same thing as your derivatives. So you can put the square brackets n, then your y then x, then it becomes partial y partial x like n times. But also if you're doing like multiple variables, right? You're differentiating with respect to multiple variables. You can do this thing where you specify multiple variables. So you put y as the top, then differentiate with respect to x, then differentiate with respect to z. So like this. So you can do that. Yeah, you can do yeah. You can it's really so simple, it's so concise. Just like a few letters, and then you can define this, which is quite cool. Integrals. So integrals, right? All you have to do is just call this command int /int, then x dx. Anyone notice a problem with this one? There's a problem here, you know. This is actually kind of wrong. Okay, so this is kind of wrong because normally you will have a spacing between your function and your dx, right? You notice there's no function here. So it's like integrating x dx. So it's like, you know what I mean? So it's like, if you, and it becomes quite problematic if let's say you have very long functions and stuff like that, and you have to have the spacing to know what, to clearly see. It's just easier to read if there's a spacing in between. So this is not really correct. If I want to force the spacing in between my x and my dx, right? Even though I put a spacing here, it doesn't show up on the right? So if I want to force this spacing here, what do I have to do? There's two ways. One is I do a backslash comma. So backslash comma in math mode, right? The backslash comma forces a space. So I'm telling LaTeX, I want a space here. Give me the space. You put backslash comma. It gives you the space. Otherwise, you can use the, I believe the LaTeX, sorry, not LaTeX, the physics package. The physics package, you can, instead of dv or pdv, you can do backslash dd. So backslash dd x gives you this dx, which is honestly nicer than this. Okay. All right. Next, integrals with limits. So if you want your integral sign to have the limits, all you have to do is just in front of your integral sign, you do underscore 0, then caret 2 pi. So remember, if you don't put the curly brackets here and encompass the entire thing and cover and close the entire thing, you will notice that you will just have a integrate 0 to 2, then your pi will come down over here, which is not what you want, right? So you have to make sure you will do a curly brackets on this area. All right. Okay, quite a lot already, but don't worry, bear with me, okay? We're going to go through every single one of this. Summation notation is the same as integrals. So it's exactly the same format. Instead of int, you call backslash sum. So backslash sum, then the thing appears, then n. Or if you want the limits, right, then you put backslash sum, then you specify your limits, then caret the top limit, then n. Then you console like this. Okay, similar rules as your integral. Okay, matrices. Matrices are very interesting. So you can specify matrices in LaTeX, but how you specify them is quite, how to say, it can be quite tiring at times because you have to type out a lot of stuff. So what you can do, you want to write a matrix, you have to write this. So inside your equation, you begin your equation first. Then you click, you don't click, you type out begin matrix. Begin matrix, then you specify the first row of your matrix. So to separate the entries, right, you put this thing over here. Why is my mouse not showing? Well, okay, anyways. So you specify your thing over here, the little the n symbol, which we call an ampersand. You specify the ampersand to separate in between entries. So one, you put, let's say you want to do the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see how it's done here. 1, then I want the next element, right? N, then 2, then N, 3. Then, okay, I'm done with this row. I want the next row. You do a double backslash. The same thing, remember, matrix, double backslash is like enter, right? It's like going to a new line. Double backslash, 4 and 5 and 6. Double backslash, 7, 8, and 9. So the last line don't need double backslash because you're done already. What? So N matrix, then N equation. Notice something interesting? The matrix got no bracket, right? So like, huh? So if you want the bracket, instead of using begin matrix, you can put begin P matrix. So begin P matrix has the bracket. Okay. If you are the kind that I don't want the curly bracket, I want the square bracket for my matrix. That's fine. Instead of begin P matrix, you put begin B matrix, then it becomes a square bracket. Now, for example, if I want, let's say I'm calculating a determinant, right? For example, then I want to show that I'm calculating a determinant. So what you all normally do, you all do the straight lines, right? In between your matrix. So how do you do that? You can do the same thing also. Instead of B matrix, you click begin B matrix. It becomes the 2 lines. So it's like your determinant like that. All right. Okay, brackets. Sounds simple enough, right? Just type the bracket, what? Like, you know, it's like dv, yeah, you put the differentiate with respect to t, then your bracket, right? Then whatever, then another bracket over here. So you can see how it shows up, right? Does it look nice? Something is wrong, right? Why are my brackets so small? You know, it's like what like how do I get it to cover the entire thing? So this is not really correct. It looks very ugly, right? Because your brackets are so tiny and stuff. What you can do is that, once again, the magical physics package comes to save you. You import the physics package, then you click / quantity. So I don't know if this actually stands for quantity, just QTY basically. QTY, then you do your brackets. So then the physics package knows that, okay, I'm going to help you size your brackets up to the correct size. So this looks so much nicer, correct? Same for the inside. You see the inside, the round brackets, / QTY, and the round brackets. Now your brackets are the right size. Cool. Multiple lines. Okay, so now I want to, let's say I want to show that I'm doing a derivation. So I want to do multiple lines, correct? I want to say this line, I start off with this, then I got this, then I got this. So let's say you are working through a derivation, right? How do you do multiple lines? So let's say if I were to do begin equation, then I type my first line. Okay, then I click enter. I type my second line. Okay, I click enter. I type my third line. Okay. Do you think LaTeX is going to nicely segment the line for you? Unfortunately, not really. And not at all actually. So you just what comes out is actually this mess. Okay. What I'm showing you right now, so you might think that my cropping is really bad, right? Like, why do I cut the M off? But this is really what happens. It's like your equation runs off the page. So this is terrible and it's a mess. It's not what you want, right? So it's wrong. Okay. Then I remember, oh, just now, I seem to recall that the double backslash is like an enter. So I just at the end of every line, I put a double backslash. That should solve it, right? That should give me my lines, right? Okay, so I go and put the double backslash. Then I click compile. And then the results come out like this again. Then I'm like, wait, that's not what I want. You know, so this is also wrong. Yeah, so then how do I get my lines? You know, so if you want multiple lines, right, what you have to do is, instead of calling begin equation, you have to call this thing called begin align. Begin align. This is a bit small, sorry, please forgive, but I couldn't squeeze it in the box. And there's so much going on the page. But you click begin align, okay? A few things to take note. The double backslashes should still be there. So if you want to start a new line, you tell LaTeX you're starting a new line by double backslash, okay? I want you to notice something on the right. The right, my equations are nicely lined up along the equal sign, right? Like they're nicely lined up along the equal sign. How do I get LaTeX to align it across the equal sign? Basically, every time you do a double backslash, right, make sure you include in the equation the area where you want LaTeX to align to. You put this ampersand. So it's the and symbol. This is how you tell LaTeX, I want you to align to this point of my equation. Okay, so you see the bottom, my equal sign also has this ampersand. And then there's an ampersand, and then there's an ampersand. Okay, so the double backslash is for, the double backslash is for that. Sorry, not the double backslash, the ampersand is for that. It's for alignment. Okay, remember just now I told you all the and symbol is a special reserved symbol. It's reserved for reasons like this. Okay. But you also notice something, like, every line of my derivation has a number. That's not what I want. It's quite ugly, right? So if you want to get rid of the number, all you can do is, remember, an asterisk symbol sometimes changes the environment. So let's go try that. At the end of my begin align, I'm going to put an asterisk. What happens? My equation numbers disappear. Same for begin equation. Remember begin equation, you put an asterisk, then the number disappears, right? So begin align, then you put an asterisk, then equation number disappears. Okay, but then if you are the kind that wants to label your equations, like the last the final result, right? Like you're so happy I derived the final result that I want to quote this equation later. I want to say equation 1. From equation 1, as you can see, I've derived this. How do you make sure that only the last line has the equation number? Okay, this is quite a long command, but you can call this thing the add to counter equation 1, then backslash tag, then open curly brackets, the equation. Okay, so a lot going on here. Let me just break it down one by one. What's going through LaTeX? What's going through like LaTeX fake mind? Okay, it's computer mind. What's happening? You call the command add to counter. Add to counter just basically means you're adding to a counter, right? So, just now, remember before this we have equation like what? 22. Okay. Then next in line is 23, right? So you're telling LaTeX add to counter 23. As in add to the counter of my equation number counter, add 1. So you say add to counter, then you say equation to tell them I'm adding to the equation counter. Then you click 1. You type in 1, right? To tell LaTeX add 1 to my counter. Then you call the function tag. So the tag function basically tags the equation to a number. Tags a number to the equation, sorry. So in the curly brackets, what you do is you're telling LaTeX tag the equation number. The backslash the equation is basically tag the equation number. So if instead of putting the equation, you say tag 3.14 instead. So inside the brackets, the equation number becomes 3.14, for example. Okay, so this is what LaTeX is doing. Okay, this is how you get the equation number on the last part. Right, referencing equations. So let's say I finally derive my final result, right? I'm very happy. Then I say, we can see that from this equation, equation 24 is my conservation of mechanical energy. Then you type in here equation 24. Because it's equation 24, it's equation 24, so I type equation 24. Then what happens when, let's say I revise I'm looking through my report or whatever, right? Then I missed out something earlier on. Then I add some stuff earlier on. Then you add some more equations. Then all your equation numbers below were from equation 24. Let's say add 1 equation below. Then what happens? This becomes your new equation 24. Then this becomes equation 25. But you have typed in your document equation 24. So what will appear is that you will still appear. We can see it from equation 24. So how do you get the referencing of the equation to change with the equation number also changing? So this is wrong because if you were to edit your document, you have a really hard time going through all the previous parts of your document to change all the equation numbers manually. So what should you do? You have to do 2 things. First of all, you should label the equations that you're referencing. So if you're referencing the equation, you can see label your equations. So you begin the equation and you do backslash label. Okay, label, then in the curly brackets you label what you want to label. So when you label it, right, it doesn't appear on your PDF document. It's just for your own reference that I'm labeling this equation. So, and because the label function, okay, this is a bit tricky. You will see later, right? You will see later the label function. Is used for equations and figures. So if you don't specify what you're labeling, when you call the function later, you'll have a very hard time figuring out what the heck you're calling. Okay, as in when you reference the equation number later, you have a very hard time figuring out what you're calling. So if it's an equation, I would recommend it's good habit to just put label equation, then dot dot, then what's this equation? Okay, so you can put this conservation of energy, so I've just put COE. So we can see that equation, then I reference my equation. So I reference equation COE is the conservation of mechanical energy. There, 24. It shows up magically. It just knows how to change the LaTeX document knows how to call the equation numbers normally. Okay. All right. That's all for this portion. Is everyone okay? It's a lot, right? Oh my goodness, equations are so much. Yeah, but we are physics majors, right? So equations are all bread and blood and everything. So yes. So yes. So any questions? It's a lot. If not, then we will jump over to Overleaf. If you want a break right now, please feel free to go. We are going to just cover the exact same things that we'll be talking about. Okay, real quick on Overleaf. Okay. Right, so anyone remember what was the first thing we covered? First thing we covered is the basics, right? How do we write any equation? So let's begin a new section. Equations. Okay, so one pro tip for LaTeX: always compile as you go. Okay, so you know that you are doing the right thing. If you ever run into an error, you type a bunch of text, you type a bunch of equations, then you run into an error, right? You don't even know where the error really comes from, or like what's the deal, because you're not compiling as you go. Even as you're typing equations, you should type a little bit then compile as you go. Okay, as a pro tip for a beginner. Honestly, also, yeah, it's what I always do, because it gets, like, especially with typing super long equations, it gets very confusing. Okay, begin. Equation. Okay, if you're using overleaf, it will just very nicely give me the begin and end equation. But I don't know if all other LaTeX softwares use this. So remember what I said just now, if you want to type an equation, what do? You can just type. 2D sine. Okay, so remember what I told you. Let's say 2D sine theta equal n lambda. Okay, you notice that I made an error, right? On purpose. What's the error? My sign is not / sign. So what's going to happen? Look at that. It's quite ugly, right? As in, can you really tell it's 2D sine theta? Or is it 2 times d times s times I times n times theta? You know what I mean? As in, it looks very ugly. So what you can do?
Justin, do you want to zoom in on your, like, for the PDF side, right? Can you zoom in a bit more? Because we can't really see the equation deck.
Oh,
yeah,
sorry.
Okay. It's better.
Right. Got it. Okay, so remember what I told you the proportions are very off. It's because I purposely enlarge it for you all to see. So right now I'm going to purposely enlarge it for you all to see. But you all don't have to do this. Okay, I'm going to purposely enlarge it by using this command, huge, because I want it to be huge. Look, it's huge. Okay, so can you all see better? I hope so. Okay, if you all cannot see, please let me know, okay? Yeah, so this is how you type in your equations. What are the equations? So we now move on to fractions. Fractions, once again, begin the equation. Fraction. What's your favorite fraction? I don't know. I don't have a favorite fraction, but let's start, let's do 3/2. Okay? So 3/2. So 3/2. So simple, right? That's all you have to do. Yeah, okay. Notice that LaTeX labels every single equation. So if I don't want this, like 3/2 is such a, what does it even mean? It's not even, I'm never going to reference 3/2. So if I don't want the equation number over there, I can just put star on the equation, at the back of the equation, the word equation, not the actual equation. So no, the number disappears. All right. Okay, what other things? Begin equation. Okay, superscripts and subscripts. Do you remember what you all need to do? Let's say I want to type in the formula for kinetic energy. So my kinetic energy, I label E, but I want to know this E is kinetic energy, right? E underscore K equal to, then maybe it's P squared over 2M. Yes, P squared over 2M. So, right? Okay, you can, maybe if you want to keep in the habit, you can always fill in your brackets first before you put in whatever you put inside, because that's what I normally do when it seems like a very simple thing to keep track of now, but when you have a really long equation, then you will notice that you have a lot of, like, you have fractions inside fractions, for example, like fractions inside fractions to the power of a fraction or something like that. Then there are so many curly brackets, so it's a bit hard to keep track. So sometimes if you want to just key in your curly brackets beforehand, you can always do that. I think it's decently good practice. So superscripts, caret underscore is subscript. Okay. Right? No problem, right? Begin a new equation. Now, if I want to type a word, remember, I have to encompass the entire word in the curly brackets. Right? You run and then you see the entire word total is inside the curly brackets. If I erase the curly bracket, you will notice it just says E underscore T, then auto, right? You all see it? Right, so I don't want that. That's nonsense. Make sure you encompass your superscripts and subscripts in curly brackets if you are typing more than just one character. Okay? Right. What else did we do? We did derivatives. Okay, so remember how to do derivatives? You can just do dv. Okay, dv x. What does this give me? D over dx, because I only specify one variable. I want two variables, for example, like dv differentiate with respect to x. If you differentiate y with respect to x, what is that? That is just dy dx. Okay, I'm just doing this so to show you. Okay, obviously it's quite simple stuff. Right, so you can see the dv function allows you to do this kind of fancy stuff. Okay, I want to do n derivatives. I can do dv, specify in square brackets, how many derivatives do I want to do? Then y, then x. So you can see now, it has the dn, dy, then dx, like n derivatives basically. So if I want 3, I want to differentiate 3 times, like d cubed y dx squared cube, d cubed y dx cube. Okay, so I just change the n to 3. Wait, can you see the little code here? Is it very small? I don't know how to make it bigger. Yeah. I just okay, I'm just gonna hope that you can see because I don't know how to make this bigger. Can you see? Okay, I just hope you all can see. Okay, you all can see. Okay. Yeah. Okay. So we move on now. Integrals. Oh, okay. We do. Do I need to show partial derivatives? You all know it's PDV, right? PDV. If you do x, it's just partial derivative with respect to x, right? Right. Okay. Cool. If I want partial y over partial x, PDV y then x. So your numerator always comes first, then denominator. Okay. If I want to do differentiate with respect to multiple variables. So I want to differentiate with respect to x first, then I want to differentiate with respect to z. So I want to differentiate y with respect to x first, then differentiate with respect to z. So there we go. Okay. Right. Okay. Integrals. INT, that's all. Remember? INT. Okay. Integrate, let's say x, dx, x with respect to x. What do I get? Integrate x dx. There's a problem, isn't there? Right. Where's the spacing? So there's 2 ways to fix this. One, you can force a spacing. Remember, / comma forces a spacing. But my d is still kind of italicized. It's not really what I want. So what I can do instead is use the LaTeX function dd. So / ddx. There you go. So there's a spacing, okay? Okay. I want limits. Limits, what do I do? Underscore. Okay. I want to integrate x from 0 to 1 for some reason. Okay, just put underscore 0, then caret 1. Right, there we go. Okay, so remember just now when I told you about the integrals being in display format, the physics package actually defaults all the integrals to physics to display format. If you didn't import the physics package, actually what happens is that your integral sign becomes very tiny. If you are using the exact same, if you type the exact same thing, and I'll show you all that later. I'll show you all what happens if you remove the physics package, what happens. Okay, everything collapses. Like everything is really like, the physics package has a bottom, then you just build everything on this physics package. You take away the physics package, just everything collapses. So I'm going to show you all that later, okay? Right, what else have we covered? Summations, I guess, which is exactly the same as integrals, right? Sum, n. I want to sum over all n. Just click / sum n, right? Simple. underscore. I want to sum n from n equals 1 to capital N. What do I do? N equals 1. Encompass it in my curly brackets, okay? Then to the caret, capital N. Wow, look at that. Right. Okay. What else? Oh man, do I show you all matrices? Okay, matrices. Let's do it. 1 and 2. Okay, so I want 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 1, first entry, 1. I want the next entry, n. Okay, so I'm telling LaTeX I want the other entry now. I'm going on to the next column. Okay, 2 and 3. Okay, I'm done with this row. Okay, I want to move on to the next row. What do I tell LaTeX? Backslash, double backslash. Okay, then I type in my next row. 3, 4 and 5 and 6, double backslash. Okay, next row. Okay, if I stop here, you'll just get a 2x3 matrix. You see? Okay, wait. So begin matrix. Okay, sorry, my mistake. And matrix. Okay, sorry, my bad. You'll see I'll get a 2x3 matrix. There we go. Okay, and without the brackets. If I want the brackets, P matrix, right? P matrix. There's my brackets, okay? So it's a 2x3 matrix. Right, then I want to specify, let's say I want to specify more rows, I can just add 7 and 8 and 9. There we go. Okay, so so actually in the physics package, there are a lot of ways that the physics package has made it easier to specify matrices. Like I don't remember what some of the commands are, but like you can like literally code backslash like Pauli and then like click 1 and then like it gives you your first Pauli matrix, for example, that kind of thing. So like, or like I think you can, there's a function for 0 matrices. Like if you want to click an n dimensional 0 matrix, then you can just click backslash 0 or something like that. I'm not really sure exact commands, but you can explore the physics package to learn how to see, make some matrices easier, okay? Because I don't have so much time, so I cannot cover everything now. I mean, if you're high in demand, maybe you can always ask for maybe a round 2 of a LaTeX workshop, maybe more advanced. Okay, multiple lines. So did I miss anything? Multiple lines. So next, multiple lines, right? So okay, what's a good equation? Okay, I don't know. 1 plus 1 equals to, no, okay, let's do 1 plus x equal to 3, okay? Then if I were to continue this, x equal to 2, x equal to 2, right? So you expect 2 lines, right? But that's not what happens, right? So you will see this mess lah. Then you might think you can do a double backslash, right? Then it moves on to the next line, right? But remember what I told you all, it doesn't work. So I can prove to you all right now, it doesn't even do anything. Okay, so it just rams everything in the same line. So what you need to do, change to begin a line and end a line. Right, then you compile and then you notice that if you put the double backslash, then everything, yeah. Okay, in this case, I got lucky. My equal signs align normally, but normally if let's say I were to do something, let's say quite funky, like maybe I do like, I don't know, plus 1 minus 1, for example, plus x, I don't know, something like that, okay? Oh, okay, I don't know. I want this to fail. Okay, wait, plus 4 minus 4. I don't know why it's aligning, but okay, normally you have to put the ampersand. There we go. Okay, so it doesn't align, right? So if I want it to align to the equal sign, right, I have to put the ampersand. Okay, this little and symbol. There we go. See, it aligns to the and symbol. Okay. Yeah, it aligns according to the and symbol. Okay. And if I don't want the equation numbers, what can I do? I just put a star behind my align. Then my equation numbers disappear. If I want to label the last equation, what was the super long command? I'm sure when you do it, oh, okay, now I'll find it. Okay, I just trust that when you all get the slides, you'll try by yourself. If you all want to like play with the last equation, put the number in the last equation. Okay, but this should be good enough. Okay, remember when I told you all what's the power of the physics package? So now I'm just going to remove this entire package. Okay, first of all, I'm going to remove the physics package only, okay? I'm going to show you watch as everything collapses. Yeah. Look at this. So there are a few things that are still in place, okay? But some things collapse already. So what do I notice? My derivatives are gone. Okay, my integral is a bit gone. But what's holding this? What are holding these together is the math packages. Okay, the math packages here. That's what's holding all of this together. So now if I remove the entire thing, if I don't even import packages at all, right? If I don't even import packages at all, what do I notice? Everything collapses. Like, look, fractions still stay there, but only the backslash frac. If you do the d frac or t frac, actually you'll notice it collapses. Then my derivatives are gone. Look at this, my integral shrank. Okay, because this is the integral that is not in display mode. So physics and math packages help you put it default in display mode. My summation becomes like that. Okay, what the heck is my matrix even? And my equations become all over the place, right? So in fact, I'll show you the physics package is so powerful that if you just import the physics package and you don't even do all the math packages, I believe everything should just come back to normal. Look at that. Do y'all believe the power of the physics package now? Yeah, it's amazing. It's really, really great. So yeah. So please, so key idea, okay, in all your LaTeX documents, when you all start your LaTeX documents, over time you will feel that you will notice you add more and more packages because you notice that you will need more and more packages to fulfill more and more functions. I think the recommendation is just every time you start a new LaTeX document, you take out your previous LaTeX document, copy and paste all your list of packages, slam them into your new LaTeX document. Okay, so let's say we're going to start a new LaTeX document. I'll just copy and paste all my packages. Copy, then I start a new document, then I paste. Okay, then I just copy everything over. Okay. All right. Okay, now I'm just going to hand over to Darren, who's going to teach you all about figures and tables. Right, so I'm going to stop share. Oh, wait, Darren, do you want to share screen or do you want to use my screen?
I will share the screen on my side instead so that I can control it.
Okay, so yeah, now we're going to hand over the time to Darren. Yay! Okay, so I'm going to stop share.
Give me a moment. Let me find there are too many. Okay, so give me a moment. Okay, yeah, so next on we'll move on to your tables. So for tables, like the code is just like this. Just ignore the slash new page. I accidentally included that in. Yeah, but basically slash new page is just the command if you want to start on a new page. Like for example, you type something halfway, then you want to start all your content on a new page. You just put the command slash new page, then it will just jump to the next page. Okay, so I will just run through the section of code over here, from the begin center to the birth table, so on and so forth. So begin center and end center is just the environment to tell LaTeX that you want this entire, that you want everything to be centered. Because if I don't put begin center and slash center, it won't be centered. It will be like left aligned instead. Like it will be aligned with the sentence instead. So I put begin center to center it. It's just to look nice. You don't have to put the begin center, but you should. Okay, so next thing, you want to do the table, right? You need to do the table environment, which is in LaTeX is tabular. So you begin tabular, and you must remember to end tabular. So after tabular, you will have you have some curly bracket with the vertical line and C. So basically, this is to tell LaTeX where you want to put your vertical lines and then how many columns you want to specify. So for this case, I want to specify 3 columns, and then between each column, I want to put a line. So between each column, I want to put one line like this. Then for the last one, just to show as an example, I want to put 2 lines. So I just do 2 lines without anything in the middle. Then LaTeX will read this as you want 2 lines at the end. If you want 3 line, you put 3 line. You want 4 line, you put 4 line. You want as many line as you want, you just continue putting the line. Yeah. Or then also if you want to put 2 lines between these 2 columns, then for this vertical line, you just replace with 2 lines. Yeah, so it's very simple for the number of columns and number of vertical lines. Then next, we need to tell LaTeX that we want to have horizontal lines. So we have the command /h line. So this /h line will correspond to this horizontal line over here. Then the second h line will correspond to the second one. Then we note that for the second and third row, I didn't put any command to tell that to say that I want a horizontal line. So you see my second and third one has no horizontal line. Yeah. Then from earlier in the matrices, this has a very similar structure. So for each element, you can just type your element, then n, then the next element, and then n, then the last element, then n. So like this, you will tell LaTeX that this is for the first column, this is for the second column, this is for the third column. Then at the end, you want to move to the next line. Remember to put your double backslash to tell LaTeX I want to start a new line. So this is how basically how you can type your table. So then this looks very similar to the matrix environment that Justin talked about. But then one important point to take note of is that the matrix environment is a math environment. So in the math environment, when you put like sine, cos, exponential without the forward slash, right, it will just take the s as a variable, I as a variable, n as a variable. Then it will italicize it and then will squish it together. But in this case, this is a text environment. So for example, if I put like instead of 0, 0, I put ABC here, you will just display ABC normally. Like for example, if I put the from here into here, it will just appear as the word the in the first in the row 1 column 1. Yeah. So this is just something to take note of for the table. Yeah. Then let's say for a table you want to put a caption for the table. So what we do is we can have the command /caption off. Then you want to tell the command that you want to label a table. So your first argument of the command will be table. So so the first command will be you want it to be a table, you want it to be a figure or whatever. So you need to tell it I want it to be a table. Then the next thing is what you want to label it as. For this one is a simple table, so I will label it as a simple table. So you see caption of table, a simple table will give you table 1, a simple table. Yeah. Then the caption of will take care for you. For example, this is your first table, so it will be table 1. Then if you have table 2, table 3, table 4, it will follow according to the label that you give by caption. So for example, if you have 3 tables, but then only the first and the third table is only the first and third table is like only the first and third table is labeled with caption off, right? Then you only have table 1 and table 2. Then the table 1 and the caption will read table 1 and table 2. Then the second table will not be labeled as anything. Like it will treat the first and the third table as the first and the second table in the caption. Okay, this one maybe it might not it might be confusing when I say it, but later when I show you an example, it will be clearer. Yeah. Then for equation, you remember that Justin said we can label equations, right? We can also label table. So in this case, we have /table with the curly bracket. Then tab is to tell the command I'm labeling a table. So I label the table as simple table. So LaTeX will take into account that this is a table, and I label it, and then it will take note that it's table 1. Then for example, so I can reference it later on. So for example, in this sentence, I write the above table, bracket table, reference, tab, simple table is simple, right? So reference is telling you that I want to refer to something that I labeled. So in this case, I reference the table, simple table, which is given by this tag by this label. So basically, since this is table 1, it will put 1 here. Yeah, so this is just a simple table example. So yeah, so later on when I show you my LaTeX code, I will copy and paste it into the chat. Then you can copy and paste into your text document and then try to run it for yourself. Okay, so this is a very simple example of a table. So we can do slightly more complicated table with like more columns and more rows. So for example, this is a slightly more complicated table. So this one is, for example, we did some experiment on diffraction spectroscopy. So you can see there's many columns, and then there are many rows with many commands used inside. So yeah, so this is basically it. So like you see horizontal line 2 times only for these 2 horizontal line. And the last horizontal line. But everywhere else in between there's no more horizontal line. Then your vertical line is taken care of by your vertical lines at the start. Yeah, so this is just to show you what a slightly more complicated example of a table can look like. Then we will now move on to figures. Okay, so the thing is that, let's say we want to insert some figures or we want to insert some PDF into LaTeX. So the thing is that I won't be going through how to do it on Text Studio or this. You can probably go read yourself if you're using some online, some offline editor. But I will just go through the way that we are doing it for Overleaf. So to insert figures and PDF into a Overleaf text document, we must first upload it. So if you open up your Overleaf, you can see at the top right, on the top left-hand corner, there will be like these 3 buttons. Like there will be these 3 buttons. Then the most right button will be the upload symbol. If you click on it, then it will ask you what you want to upload. So in this case, you can upload like a image and upload a PDF. So because later on we'll be inserting a image and a PDF into our LaTeX document. So we insert the so after we upload, then you upload it already. So now LaTeX has the document. So to insert figures, we need to, after we have to obviously use the package graphics, then we need to tell LaTeX where is our graphics located. Since we are using it online, it's just graphics path curly bracket with no argument inside. Like if you are using offline one, you need to specify, oh, I want to look into this folder and so on and so on. But then in this case, since we are doing it on Overleaf, then it's just empty. Yeah, like if you are doing offline, then you have to look more into this. But yeah. So to insert a figure, so once again, we need to have the begin center and end center to center our figure. Otherwise, it will be offset. It will be left aligned. So we have the begin and the center environment. Then next we include graphics. So we have the command include graphics. Then we can specify the scale of the graphics. So for example, like this one, the original size was quite large, so I need to shrink it down. So I put scale 0.18. Then followed by the document name, followed by the picture name. In this case, my picture is intensity versus vertical position dot png. So in this case, I just put intensity versus vertical position. The good thing about LaTeX is you don't need to specify the file type. Like you can if you want to, but you don't have it. LaTeX will it will run through all the files, and then it will just see whichever correspond to it. Yeah, but like in the case that you have multiple documents with the same name, then you have to specify. But in the case that you don't have the same, they don't have the same name, then you don't have to specify. Yeah, so then followed by your file name. Then followed by that, then we have the caption. So just now the caption off. So followed by caption off. Remember for tables, we have caption of table. But now since we are doing a figure, we can put caption of figure. Then followed by the figure, like what you want to label the figure with. So in this case, like weighted non-linear least square feet of something against the vertical position. Yeah. So it's just like that. Then we can do similar thing for the label, but then label followed by, I can't remember what's the short form for figure. Like for table it's tab. For figure, I think it's FIG, but then I can't really remember. But then this one you can just Like when you need to use it, you just Google it. Like that's the main point that you should take away from this. Like there's something that you're not sure, you can just go and Google it. Instead of trying to remember, or I want to type this, I want to type that, then you recall. Just Google, honestly. Like even when I do LaTeX now, I also just Google. Like for the thing that I can't remember. Yeah. So for inserting PDF is we can just like after you have the command, after you have the package right, then one of the package from earlier is to help you insert the PDF. So what you just do is /insert PDF, include PDF followed by what pages you want to specify, followed by what pages. If you only want to insert one page, then you just put page 1. If you want to like page 1 followed by 3 then 5, it should be 1, 3, 5. Yeah. Then after that you specify the PDF name. Yeah. Then one thing to note is that this doesn't need to be in 2 separate lines. You can have it in 1 line by itself. Like I just do it in 2 lines so that when I screenshot it will look nicer. Otherwise it will be very small, then you can't really see what I type. Yeah, then the output, I can't really show you the output now. I will show it later. But basically, like wherever you will insert into the text, into the LaTeX code, it will just throw the PDF inside there. So for example, like you have one page followed by include, like you type something, you include PDF, then you type something else. So your first page will be whatever you type. Then it will be the PDF that you put in, that you upload, that you include. Then then followed by whatever else you type. Yeah, I will show it to you later on. Yeah, then the last part, which is the more complicated one, and I would suggest that you don't really need to use the graphing technique, the graphing functions in LaTeX. You can always just use, like, I know like for lab you do data analysis. You don't do your data analysis in LaTeX. You do it in Excel, or you do it in Python, or maybe MATLAB or whatever. Like those programs itself have some built-in graphing, have some built-in graphing functionality. Just use that graphing functionality, and then just like screenshot or save the graph, then insert it as a figure into your text document. It'll be much simpler than trying to work with the LaTeX code. Yeah, it's much simpler. So so now we move on to the example for graph. So we start off with starting some environments. So it's text, picture, and axis. Then followed by like we can start label. Then we have to tell the axis what we want it to be. So like title, a simple example. So the title, a simple example. Then the axis line, I want to define it to be on the left. Like you can define it to be the left, onto the center, to the right. For this one, you can just go look at the documentation, or just search online. Like they will tell you what are the different options you can have to specify where your axis lines are. Like yeah, there's a lot. Followed by the X label. Like yeah, I didn't realize it got cut off. Yeah, so there should be an X over here. Like the $sign here is just to make it italicized, just to be the max mode. I don't necessarily need to include the $sign there as well. I can just put X. Then it will just be an X that is not italicized. Like for example, the X in example will just be the X here instead of the italicized X over here. Then the Y label is just FX. So Y label FX. Then I want the range for the X values. X minimum from 0 to 100. Then the Y values from 0 to 5. Then I want it to know what are the intervals for the, like what are the intervals are. So in this case it's 0, 20, 40, 60, 80, 100. There is probably a function that can also help you specify I want it to be every 20 or something, but like there is probably some function somewhere inside the package, but I will not be covering that. I will just be doing the bare minimum that you need just to draw a graph. So you have 0, 20, 100, 0, 20 up to 100. Then for Y, similarly from 0 to 5. Then I want to specify where I want to put the legend. So in this case, I put the legend in the northwest, which is the top left corner. Like don't ask me why is it northwest. whoever wrote the package defined it to be northwest. I don't know why they use compass position instead of like top left or top right. That the one I don't know. That one you have to ask whoever defined it that way. Yeah, but basically a lot of this is the person that wrote the package defined it that way. So we just follow. Then next thing is to specify I want the grid lines to be there. If not you won't see all these grid lines. Yeah, so just y major grid lines true, x major grid lines true, and there's also the functionality like I want the grid lines to be dotted or whatever, but you can go and read up. You can go read that by yourself. Then lastly, we can finally plot our graph. So we have the command app plot. Then we specify the domain. From the function will be from 0, the domain will be from 0 to 100. Then sample is basically the way, okay, because the way LaTeX sketch graph is, it plot many points, then it connect each of the points. So the more samples you have, the smoother your graph will be. So for example, for this, I have 100 samples. So it will give me a very smooth red color curve, as you can see over here. Yeah, then the color is red. Yeah, red. Then followed by whatever function I want to call. So in this case, I just call lonx. Then I put the semicolon at the end. Then next, I put add legend entry. So it's just to tell LaTeX that this graph, what should the legend be? In this case, it will just be lonx with 100 samples. Then I can do similarly for the same function, but I do less samples. So you see for 10 sample, the line is actually like not as smooth. Like you can see it's one straight line here, one straight line here, one straight line here. And then towards the end, because there's less variation, so the straight line you can't really see there is multiple straight lines just connected. Yeah, then you can see that for this portion, there is no line at all. Like this is because we only specify 10 samples. Yeah, so if you specify more samples, it will be better. But then again, it will take longer for your code to compile. So like the number of samples to choose is up to you. Like you can just try 100 first, then you see how fast it runs, and then see whether does it give you a good enough graph for your purposes. If it's good enough, then okay, 100 is good enough. Or maybe if it's too slow, then you can try reducing maybe 50 samples. Then you can see whether the graph is good enough for your purposes. If it's not good enough, then you can try increasing it again. Yeah, basically it's up to you to decide how many samples you want and whether it's good enough for you, and then how fast it runs. Yeah, but then basically all the different arguments for what color you want, where your position of where you want your position of your axis line to be, where you want your legend to be. This one you can just go and Google, because there's there are many different things that you can tell the function, but I'm just giving you the most basic one. Yeah, then this is another example of a graph. So again, we begin our tick and we begin our environment, the tick picture and axis. Then we do the title, the labeling, the range of our x and y value, then our legend position and so on. But now, instead of specifying the function, I will specify some coordinate points and then I will connect them with straight lines. So in this case, our function is x squared. So we have 0, 0, 0, 1, 1, 2, 4, 3, 3, 9, 4, 16, so on and so forth till 10, 100. So I have to painstakingly specify each coordinate inside the function. Yeah, then one more thing for the app plot one, right? Just now for our app plot, since we define the function instead of the coordinates, is domain, samples, and then the color. But now since I define the coordinates, the domain doesn't really make sense, as well as the number of samples, because it doesn't know what function you want it to sample, and then you also don't know like what range you to sample for. So in this case, we have instead of those, we have a new option called mark. So mark square with an asterisk will give you like this solid red color squares. Like I think if you just put square without the asterisk, it will give you a hollow square or empty square that's not filled. Yeah, but then for the options on mark, you can just go and take a look online. Like there are very nice documents on the overview website that will tell you what the options are. Yeah. Then this one is just, then I put the legend. This one, like I'm not really sure why it's just legend as compared to add legend entry. But for this you can go and play around. Yeah, like then one thing that you can take away from this is feel free to just go and play around with your code. Like you can modify a bit, then try to compile. Modify a bit and try to compile. Like there's nothing wrong with that. Like this is not a test environment where you must get the where you must get the text code correct the first time. You can play as much as you want. It's like it's not as if your computer will explode or something if you compile wrongly too many times. Yeah, so have fun, just go and play around with your code. Then if anything goes wrong, you can just go Google. You don't know, you can just go Google. Yeah. Then for the last thing that I want to talk about is the multi-column environment. So you know when you read those research paper or whatever, they do in 2 column, 3 column, or I don't know how many columns they use. So the way we can do this is to first like we need to use the package. Okay, I can't remember what's the package, but then it should be somewhere at the start already. Like, yeah, but we should have specified it at the start. If not, wait, give me a moment. Oh, share screen. Okay, like I typed the package into the chat. The package is conveniently called multi-core. Multi-core. So this package has the environment multi-cores inside it. So we can just begin the environment multi-cores followed by specifying how many columns you want. We want 2 columns, 3 columns, or any number of columns. You can just put at the the argument of the like the this argument position over here. Then after that you can just type whatever content you want. So in this case, I just put some filler there. Yeah. So this is how you do the multi-core thing. Then you notice that for this multi-column, the column is balanced. That means that both columns are of the same length. But let's say you don't want you don't want it to be the same length. You want the first column all the way down, then to start the second column. So remember earlier when we have the equations environment, we have the asterisk modifier, right? To make it whether we want to have the equation to be numbered or not numbered. So equation by itself has numbering, but then let's say we don't want any numbering. Then in that case, we use equation asterisk. So similarly for multi-cores, if you want to modify it such that we have like we finish the first column before moving on to the second column, we can use multi-core asterisk. Yeah. Yeah, then that's all I have for my section. Like now I can show you on my overleaf document how it looks like. Okay, so like this is the okay, so this is my overleaf document. So you'll see at the start I had the document class article followed by the package. Like actually this one I'm not really sure what it does, but yeah, I don't think you need to insert that. Then I have the package PDF pages to insert PDF, then all the maths and physics packages, the geometry package, then all these, then for your graphics, for your captions, and for your plotting. Yeah, then this one is just for my filler. Like this one you don't have to put there. And then the multi-core one. So you can see for this, right? Yeah, so we can see we have our begin center, include graphics, include the figure and so on. So this one will correspond to this thing, to this figure over here with this caption. Yeah, I just copy and paste the entire document inside the chat, so you can just copy and paste the relevant portion that you need. Yeah, so the graphics one will correspond to the figure. Then for this section on the table will correspond to this small simple table here. So you'll see like there's a lot of things here, but then what you output is just a very small table. Then the next thing we have is the more complicated table, which will correspond to over here. Oh yeah, then so remember when I said earlier, like let's say we have many different tables, right? Like we have 3 tables, but then we only label the first and the third one, whether will be table 1 or table 2 or table 3 or something. Then we can just try it right now. So I just copy and paste, and then I can try to compile and see what happens. And so table 1, table 2, table 3. So let's say I remove this and see whether it's still table 3. Yeah, so you see, since we never put any caption or any label for the second, like since we never caption the second table, LaTeX won't treat it as table 2, it will just treat it as some other table. So in this case, our third table will become table 2. So sometimes if you notice your numbering maybe screw up a bit, this might be one of the issues. Yeah, but yeah, so you can see if you're unsure, you can just play around with the code like what I did. It's like there's nothing to be afraid of. You can just play around and compile as you go and then see whether any errors occur. Yeah, then I think for the next part it's just the graph. Yeah, this one I won't run through. Yeah, then that you see that I include PDF here, right? So after the graph is the PDF. Is my PDF document. I put the first 3 pages, so it's 1 page, 2 page, 3 page. Then after my include PDF, I have my multi-core environment on all this. So after the third page, I will have the multi-column here. Yeah, so basically that's all I want to share for my part. Justin, do you want to share screen again? Then we can move on to the Q&A. So they can, if any question they want to ask, they can ask.
Yeah, sure. Okay. Cool. Oh, I closed the.
Sorry if my section is a bit fast because I realize we are running out of time, so I need to try to finish it.
Yeah.
But then this will be uploaded together with the PowerPoint slide. Like we'll make the changes. Like for example, the multi-core, I will include it in the front part and so on. So like I will include all those things that I never talked that I talk about in the chat, but then I never mentioned that. But it's not mentioned in the PowerPoint. I will make changes and change it accordingly. Yeah, so you don't have to worry.
Yeah.
Okay. So we move on to our Q&A. Are there any questions you want to ask us?
You mentioned about having to install me text or whatever, because previously I installed Text Studio, and only now I installed Meet text or whatever.
Okay, for this one, I'm not really sure, and then I don't really want to cover this during this session, as like this session is meant for more of an introduction to LaTeX, like to get you started on LaTeX. Like all this on offline text editor is honestly a bit of a mess also. Like when I installed it was also some problem for me. Like what I will recommend is you uninstall everything text related on your computer. You install my text first, followed by Text Studio. Like that's what I recommend. Like you don't have to worry about your text document being lost. Like you can, like in Text Studio, whatever document you have now, you can save it first. Then you can uninstall Text Studio. The document will still remain on your computer. Only the program will be removed.
Okay, I'll do a fresh install of everything.
Yes.
Alright. Is that would this Q&A be recorded?
Yes.
Yeah. What about the text chat?
I will include the information that is required into the PowerPoint slide.
Okay.
Okay, I will just give 5 more minutes. If there's no more question within 5 minutes, then I will end it. Yeah, so like you all have 5 minutes, you can just go and play around. Then if there's any error that occur within overleaf, you can tell us, then we can try to troubleshoot for you. Yeah, if it's an offline text, if it's an offline text editor, then it will be much more troublesome for us to troubleshoot, because we don't know whether is it due to your text editor, is it due to your packages, or is it due to you typing a bad code. Yeah, there's just too many variables for us to troubleshoot online. Yeah.
When will the link be provided?
It will depend on whenever YouTube want to upload, because like YouTube takes quite a while to upload. Yeah, so that one is out of my control as well. I want to release it as soon as possible as well, but then you have to see when. I will see how long YouTube takes to upload it.
Okay.
Okay. Just one more thing. Like after this session, there will be an automated email sent to you guys that we asking you to do a survey. Then maybe you can, from there you can share with us what things do you think are good about this workshop, what things are bad, what things do you think we can improve, and then like maybe what other things you think might be good for us to add in. Yeah.
Yes, please help us fill in the feedback form, guys. It will really help us. Yeah, it's like, because like I don't think we've conducted many workshops in the past, so like this will really be like this we have so much to learn. So like we really hope that you all can help feedback to us what's good and what's not good.
Yeah, I think this is the first physical LaTeX workshop.
Yeah, it's it's a new initiative started by this batch of like Fizok members. So like I really hope that y'all can help us like improve lah. Also, by the way, follow our Instagram, follow our Telegram. Yeah. But yeah, any questions, please ask. Right here. Yeah. It's I understand that it's a lot. I think I think going through the presentation also, I realized that wow, it's really a lot of information, but that's just like it goes to show just how much you can do with LaTeX.
Yeah, but I think that if you're going to do this by yourself, right, it wouldn't be as boring, because if you do by yourself, you can you realize because you read by yourself is much faster than us verbally telling you what to do. Yeah, like then if you don't know about this, like Overleaf itself has very good Overleaf provides very good documentation on the packages, like what to do. For example, you want in Maths, what can you do, all this. Like I need to find the website. Give me a moment. Like this particular website is for mathematical expression, but then over there has a lot of things. For example, you want to do matrices, you want to do figures, you want to do citation, the document structure and so on. Like there's a lot of things. Okay, like it's not that your document. Okay, I'm not saying that the document is too long. I say that if you have too many sample points, Overleaf will take a longer time to compile it. I think it will still compile, but whether it takes like 10 seconds or half a minute or like 30 seconds to compile, that one is it just means it needs more time to run to compile. It's like, for example, if you sketch a curve, you have 10 points to connect versus 100 points to connect. Of course, it will take a shorter time for you to connect 10 points than to connect 100 points. Yeah. But I don't think the length itself is an issue. It's just what you want LaTeX to compile only.
Anyways, regarding the chat, I think Sherman, maybe your concern is that a lot of the packages we place them in the chat, right? So don't worry, maybe we'll find a way to disseminate the same packages out, or we'll put it in the slides and stuff. So don't worry. Otherwise, life hack. So we should conduct a Zoom workshop, right? Life hack. So you can go to the chat, you can click the little dot, then you can download the entire chat, as a text file. Life hacks.
That one may be my issue. Because personally I don't use Overleaf. I use Text Studio, so I haven't run into any issue yet. So Overleaf is you're using the free version. Maybe they want you to buy the paid version, so they purposely limit the horsepower of the free version. Like you want to do longer document, you pay. That one maybe I don't know.